Okay, grade 9's just picking up where we left off here. Gonna whiz through a couple notes. So you were told you didn't have to finish that assignment. It's right there if you would like to. We're going to talk about comparing and ordering rational numbers. Okay, so before we go back to the assignment, let's do a little bit of notes. Little thing here, you can use greater than, less than, or equal to determine which rational number is greater where possible. So little note with these greater than or less than signs, we read them left to right, and we also have what often people say is they're eating the bigger one. So if you think of it as an alligator mouth, it's going to open towards whichever one is bigger. So this one, we want to know which one of those is bigger. Well, one we could do with that is to just punch them into our calculator and find out what they are as a decimal. Okay, another way we could do that is to use a common denominator. So we've talked before about greatest common factors. So if I think about what's the biggest number that both, or the smallest number, sorry, that both of those can go into, and actually in this case it ends up being, if we multiplied them together, we get 63. Okay, so what I want then is I want the denominator in both of these to be 63, because then it's easy to compare them. Okay, so I've got 4 over 7, and I'm going to multiply. How do I get 7 to be 63? I multiply it by 9, so I'm going to multiply top and bottom by 9. Okay, so what this gives me is 36 over 63. And I want to do the same thing with 5 over 9. So what do I have to multiply 9 by to get 63? Well, I'm going to multiply it by 7. 5 times 7 gives me 35. 9 times 7 gives me 63. Okay, so now that they have the same denominator, it's whichever numerator is larger represents the greater fraction. Okay, so this one's bigger, just barely, but it's definitely bigger. So I'm going to have the mouth open that way. And so I could say the same up here, is that 4/7 is greater than 5/9. Okay, this one already has a common denominator. I've got a denominator of 8 on each side. Now something that's really important is that they are both negative. And I'm looking for which number is greater. So the negative numbers closer to 0 is greater. Okay, so for example, if it's negative 10 degrees outside, negative 5 degrees is a greater temperature. It's warmer. Okay, and negative 5 would be closer to 0. Okay, so when we're looking at negative numbers, whichever one is closer to 0. Okay, so in this case, if they have the same denominator, we're actually looking for the smaller number. Okay, so I'm going to write under here, since negative 3, which is greater than negative 5, okay, then since they have the same denominator, we can say that negative 3 over 8 is greater than negative 5 over 8. Okay, again, with negatives, closer to 0 you are, the bigger you are. Okay, if we take a look at some notes over here, two positive fractions which have common numerators. Okay, so this is a little trick. Now they've got the same numerator. Okay, whichever one has the smaller denominator is the greatest fraction. Okay, so this is a smaller denominator, so it's got a greater fraction. Why? Well, if I think about, let's take two imaginary chocolate bars. Okay, one of these chocolate bars has 7 pieces. 1, 2, 3, 4, 5, 6, 7. Okay, and let's say the other chocolate bar has 9 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this one, 2 pieces. Well, 2 pieces of this chocolate bar are bigger than 2 pieces of this chocolate bar. Okay, so same numerator. I've got 2 of something. The smaller denominator is the one that's actually bigger. Okay, and again, that one's close, but not definitely that one of them is bigger than the other. Okay, then for negative fractions, which have common numerators, the larger denominator is the greater fraction. Okay, so again, we're looking at which one of those is closer to 0. Okay, which one of those is closer to 0? So we end up saying that negative 2 over 7 is less than negative 2 over 9, or negative 2 over 9 is greater than negative 2 over 7. Okay, because this is a smaller number, but it's negative, so it's closer to 0 than this one. Positive is always greater than negative. Okay, These fractions are called opposites, so 3 over 4, which is negative, and positive 3 over 4, so they're opposites. For every positive fraction or decimal, there is a corresponding negative fraction or decimal. So here's some more examples of opposites. Okay, so in this case, it says positive is always greater. Well, then that must be my greater number. Okay, now over here we've got a fraction and a decimal. Well, we could do two things. One thing is we could change this to a decimal and compare them, or we could change this to a fraction. Probably an easier way is to change negative 10 over 4 to a decimal. So if I go negative 10 over 4, what that really is like negative 10 divided by 4. And if I do that math, I end up with negative 2.5. Okay, so now what I'm really looking at is I've got negative 2.5 and negative 2.8. Okay, they're negative numbers, so whichever one is smaller, whichever one is closer to 0 is actually the greater number. This one is closer to 0 than this one, so we follow that same pattern up there. Okay, cruising through these examples, but please feel free to pause or stop and think about them, rewind them. You can do that with the video, so please do that. Okay, so a little hint here, or a little note, regardless of the positive or the position of the negative sign, these fractions are equal. Okay, a positive divided by a negative is always negative. So a positive divided by a negative gives me negative, but a negative divided by a positive also gives me negative. So here's 3 different ways to write the exact same thing. Nothing different here besides where we've placed the negative sign. It actually gives us all the exact same value. Okay. Last little chunk here. We're asked to place these rational numbers in descending order. Okay, in descending order, which means from largest, sorry, getting blurry there, to smallest. That's what descending order means, largest to smallest. So I'm going to draw myself a number line. And I see that I've got biggest negative, I've got a negative 5, and my biggest positive, well, let's just go to positive 5, just for fun. Okay, and let's say this is 0, so this is negative 1, negative 2, negative 3, negative 4, negative 5, so there's my negative side of my number line, and so I'm going to do the same thing over here, 1, 2, 3, 4, 5. And then what I want to do is I want to place these numbers. Okay, well, I know negative 5 would go right here. Let's get rid of that one. That one is easy. Some other ones, I know that 2 would go right there. That one's easy. I've got 0.5. So that one goes right there. I've got 1 3/4, which is just a little shy of 2. So let's go 1 3/4. I'm going to put it right there. I've got a positive 7 over 3. So what we could do is we could go 7 divided by 3, or we could change this into, say, a mixed fraction. So 3 goes into 7 twice. So this is like 2 1/3. So actually this is a little bit bigger than 2. I'm going to put it over here, 7 over 3. Now I've got some negative numbers. Well, I've got negative 3/4. So that's about right here. I've got negative 1.8. So negative 1.8. Oops, sorry, I put that in the wrong spot here. Let's change that to negative 1.8. And let's put negative 3/4 right here. Okay. And then last I have negative 3.3, so that goes somewhere over here. Okay, so I've got all my numbers and they're all in a number line. So now if I want to put them in descending order from largest to smallest, I'm going to start at the right side of my number line and I'm going to work left. So 7 over 3, 2, 1 3/4, 0.5, negative 3/4, negative 1.8, negative 3.3, and negative 5. Okay, so that is how I use a number line to order. Okay, last thing we're going to do here, identify a decimal between each pair of rational numbers. So let's say A, we've got -1/2 and -1/4. Okay, well, I know that -1/2, we're asked for a decimal here, is like -0.5, and I know that -1/4 is like -0.25. So if I'm thinking about a number line, something that's in between these, well, I could go anywhere from -0.25 all the way to -0.5. So there are actually an endless number of answers. What I'm going to do is I'm going to pick, well, what's the next smallest after this? I'm going to say, let's go -0.3. That's a nice easy one. Okay, let's say we have two decimals, so -0.25 and -0.26. Well, what's a number right in between them? Well, I got to think really small here, but if I went, and if I can ignore the negatives here and think about it this way, well, what's a number that's in between those two? Well, say 0.251 or 0.252 or 0.253 or any of those. So we can actually do the same, but I'm going to say negative, and I picked 0.255. You could have picked anything like that, but that's what I ended up. Okay, identify a fraction between each pair of rational numbers. So let's go with -2/3 and -3/4. Okay, well, -2/3 is like -0.6 repeating, and -3/4 is like -0.75. Okay, I want a number that's in between those. So this is the 10th spot. So if I think of in between these, I could say something like, let's go with -0.7. So that's 7/10. So I'm going to write that as a fraction, -7/10. Okay, another way we could do that is we could get a common denominator and simply write a number in between. So a common denominator between these would be 12. So how do I get 3 to 12? I times it by 4. So I've got to do the same to the top. So that would give me -8/12. And -3/4, well, I got to multiply the bottom by 3. So I got to do the same to the top, -9/12. Well, that one's really tough, right? Because they're so close that I can't get a number in between them. So what I could do then is just double them, make them a little bit bigger. So let's go -16/24 and -18/24. Well, what's the number that fits right in between those? -17/24. Okay, so there is another solution for us. All right, what you guys should do for an assignment, let's just take a peek in our textbook here. Definitely finish the page 101 that was assigned from before. Okay, so let's just, oh sorry, I was hopefully writing that on there. If not, pause it, you can take a look at that. Let's go page 101, number 1, all the way through 12, 13, 16. Let's go all the way to 18. Okay, number 1 to 18. Okay, that's your homework for the weekend.